Hello and welcome. So we have ourselves some right triangle trigonometry applications. Let's dive right into it. So we have a radio tower is located 300 feet from a building. All right, so let's just draw as we read here. So we have a radio tower. I don't know what this tower looks like. Bam, tower. Okay, so we have a radio tower, and from this radio tower, we're gonna have some. Ooh, that looks awkward. Some distance 300 feet specifically, until we get to a building. Okay. Alright, from a window in the building. Alright, so let's draw ourselves a little window here. And you have a person in window. Okay. Alright, so now we have ourselves, from a window in a building, a person determines that the angle of elevation to the top of the tower is 30 degrees, and the angle of depression to the bottom of the tower is 24 degrees. How tall is the tower? Well, this is kind of an interesting case. So remember, wherever the line of sight is looking at, that is your horizon. So this person is looking straight out at this tower, right? They're looking straight out at the tower, and they'd say, okay, from this place an angle of elevation. So elevation means up. So to the top of the tower, we're saying that we have an angle of 30 degrees. Now, this is obviously not the scale. Oh well, it's fine. You'll get the idea when I draw it. Okay, and then from that horizon looking to the bottom of the tower, we get 24 degrees. That's an awkward 4. Hold on. Okay, so we have two different angles, or in other words, two different triangles that get formed while we create this triangle here, this diagram. Okay, so angle of depression, depression down, elevation up, and it always go from wherever the horizon is. Okay, depression doesn't mean that your angle is down there, it is down from wherever the horizon was. Okay, alright. And then it says, how tall is the tower? So we want to find this whole length. Well, what information are we given? Well, first off, from the tower, we're told we have a distance of 300, which is going to be super helpful to us. And we know that we need to find the tower length. So that's going to be the length of this triangle plus the length of this one. So we're looking for this length plus this length is going to be the entire length. That's what we're looking for. So that means that your answer, right, your answer here is going to be whatever the x is plus whatever the y is. And you say, okay, well, great. Where do I go from here? Well, think about it. If your angle is over here, that means this side is the adjacent and this side is the opposite. And of your three trig functions that we're using here, there is only one of them that uses the opposite and adjacent. That is your tangent. This is the function you need to use. So it's alright. Tangent, what's your angle we're using for this first triangle? 30. So tangent of 30 degrees equals the opposite side, which is your x. It's directly opposite of your 30, over your adjacent, which is the 300. Okay? And that would be your relationship for x. Now we can solve one for y while we're at it, right? We're still going to use an adjacent and opposite. That's still a tangent. So that would be tangent of your new angle, 24 degrees, equals y over 300, right? Super similar on those relationships. Now I just need to solve for x and y. Well, right now, x is being divided by 300. How do we undo division? Multiplication. So multiply 300 to both sides. Then we get that x, because these will simplify, equals 300 times the tangent of 30 degrees. Y, we're told, is going to be... Oh, sorry. Let me solve this first. Same thing. Multiply 300 both sides. Not 3,000, 300. And then we get 300 tangent of 24 degrees. Meaning that the height of the building, right, not height of building, height of tower, is going to be our 300 tangent of 30 degrees plus our 300 tangent of 24 degrees. These are not like terms. Okay, don't add them together. Don't make it 600 tangent of 54. No. That doesn't work. Keep them separate, right? Your calculator can handle them separate. Keep them separate. So at this point, literally just turn to your calculator, and when you do, make sure you are in degree mode. So for the Desmos calculator I'm using, right, you'll see this little slider between RAD, radians, and DEG, degrees. You're using degrees. Make sure it is in degree mode, or else your answer will be totally off. Alright, so first one, we have 300 times tangent of 30 degrees, plus 300 times tangent of 24 degrees, right? Just put it right in, answer comes back, then we get 306, does it say what terms on this one? Round the height to 2 decimal places. Sorry. Go back and I'd say, all right, first decimal place is a 7, next one is a 7. Behind that second 7 is a 3. 3 rounds down, so your final answer would be 306.77. And that is the approximate height of your radio tower, assuming that your two elevation and depression angles were accurate. Alrighty, thank you so much for watching.